this is an example from an exam assignment from 2008. Here we have the number of weeks per year equal to 50, we have ordering cost equal to 1000, holding cost equal to 20, then we have a constant lead time equal to 2 weeks. Then for demand per week we have the average and standard deviation equal to 250 respectively. There are 5 questions. We will try to answer questions 2 to 5. And we'll do them one by one. So the first the first part that we'll consider asks us to find the optimal order quantity. So question 2, find the optimal order quantity Q. But before that, let's do some other calculations. Demand during lead time. Let's calculate the average and standard deviation of demand during lead time. The average demand during lead time is the average lead time multiplied by the average demand. So they are both in weeks, so I can do the calculations like this. So 400 is the average demand during lead time. And then for the standard deviation of demand during lead time, I need to use the same formula, if you remember from the previous examples. The formula with the square root, and if I simplify it for a constant lead time, I will get the square root of the lead time multiplied by the standard deviation of demand. So it will give me the standard deviation of demand during lead time equal to 70.71068. And I can also calculate the yearly demand. It is demand, okay, so I have 50 weeks, and in each week on average I have a demand equal to 200, so the annual demand will be equal to 10,000. In question 2, we need to find the optimal order quantity. We remember the formula, it is the square root of 2 times annual demand times ordering cost divided by the holding cost, which is 1000. Question 3. Assume that service is defined as the probability that all demand during an inventory cycle would be satisfied immediately from inventory. It means that it says all demand. It means that there is no shortages. The probability of having no shortage in an inventory cycle, which is the definition of the cycle service level. So here in part 3, we will consider service or cycle service level, the definition of the service level in the book. And what we want to do is to find the reorder point for the laptop suitcase to be used at each of the warehouses for a desired service level of this type at 99%. So here 99%, as we mentioned, is the cycle service level. I will start with calculating the safety factor, which is norm S in of the desired service level, and then I need to calculate the safety stock, which is the safety factor multiplied by the standard deviation of demand during lead time, and then reorder point is average demand during lead time plus safety stock. So 565. Yes, I'm going to round it up. So 565 is the reorder point. Now let's move to part 4. It says assume instead the service is defined as the fraction of demand that can be satisfied immediately from the inventory available. So it is the fraction of demand immediately satisfied from the inventory. It is the definition for the fill rate. So here we will consider fill rate instead of cycle service level. Again, it is 99%. It is just similar to the example that we solved. So we will start with the calculation of Gn of z. If you remember, it was Q. Here we have the Q equal to 1000. It is Q multiplied by 1 minus Fr, fill rate, divided by the standard deviation of demand during lead time, which is 0.141421. Then to calculate the safety factor or the corresponding z value, I will just take this Gn and put it in the template that we had. So I will paste it here as the target Gn, and I want to find the z value that will give me this target Gn of z. So again, I will go to data, to the forecast panel, what if analysis, then I will choose goal seek. What I want to do is to set this cell equal to 0 by changing these. And if I press OK, it will give me the corresponding z. Okay, safety factor here. Okay, so I have the safety factor. Next, I need to calculate the safety stock, which is the safety factor multiplied by the standard deviation of demand during lead time. And then the reorder point is the average demand during lead time plus safety stock. And if I round it up, okay, I will get 450 as my reorder point in order to meet a fill rate equal to 99%. In the next part, in part 5 of this assignment, it says that assume now that the service is defined by stating the accepted average number of stockout situations per year. In other words, it says the number of cycles, the average accepted number of cycles with shortage. Now we want to find the reorder point we want to find the reorder point for the laptop suitcases to be used at each of the warehouses if the company only is willing to accept an average of 1 stock out situation per year at each of the 3 warehouses. Okay, so we want to do the calculations for each warehouse, and the accepted number of the stockouts per year is equal to 1. So let's see what is the number of replenishment cycles per year. If you remember, for demand equal to 10,000 and order quantity equal to 1,000, then the number of replenishment cycles was equal to 10. So it is D over Q. Next, we can calculate the cycle service level. The cycle service level, which is in fact the fraction of the cycles in which we do not have a stockout. So here, just 1 out of 10 we are allowed to have a stockout. So in 10 minus 1, which is 9, over 10, the total number of replenishment cycles, the average number of replenishment cycles, we are not allowed to have stockouts or shortages at the end of the replenishment cycle. So it means a cycle service level equal to 90%. So the rest of the calculations is just similar to question 3. We have the cycle service level. We will calculate the corresponding z-score, which is 1.28. Then we can calculate the safety stock, which is the safety factor multiplied by the standard deviation of demand during lead time, and then the reorder point is simply the average demand during lead time plus safety stock. Of course, I am rounding it up to 491. Yeah, that is the solution to this problem.